So frequency is waves per second. We're familiar with this one. There's another important principle, and that is that the wave speed depends on what kind of wave it is. Is it transverse or longitudinal, right? We'll talk about what those are, right? Doesn't depend on amplitude, doesn't depend on frequency. Let me just show you this. I can make this medium. First, I'm just going to show you, I'm going to change the medium. It's the same spring, but I'm tightening it up. I'm also, by the way, reducing the mass per unit length. Aren't I reducing inertia? So if I tighten it up, I'm reducing the inertia of the spring, increasing its springiness. What should be true about the speed of waves on it?
Faster.
It should be fast, like, woo, dung, dung, dung. That's pretty fast, right? Here it goes. Yeah, that's pretty fast, right? Now I'm going to do the opposite. I'm going to make it a lot of mass per unit length and not very tight. And let's just see how slow we can get it to go, right? That's a little bit different, isn't it? Right? And the size of the wave, as long as it doesn't affect the tension in the thing, right, isn't going to change the speed. It's just going to go back and forth the same speed, right? Frequency doesn't really change it. So the wave speed is a characteristic of the medium that you have, and it's not a characteristic of the other things, which is good news for us, that we can change the frequency. And when we change the frequency, let's go back to this, right? What if I change the frequency? What if I make it a higher frequency? Well, it's going to go up and down faster. What's happening to the wavelength? Shorter wavelength, right? How about an even shorter frequency? Isn't that a even shorter wavelength? Right? We're dividing the same amount of distance per second into more pieces, right? Yeah?
Still doing the same thing.
Yeah, same amplitude. We can change the amplitude. Here's changing the amplitude. Really big amplitude. Look at that. Holy cow. Here's where you're really going to start voting Democrat. There you go. So this is a low frequency. High frequency, right? It's crazy. This is like the speed of the animation. That's kind of cool. Whoever wrote that is very cool. Although it seems to be chunking, doesn't it? It's like it's having a hard time. Basic wave formulas, yay. We've got those. Don't we have those? Yeah, we do. Okay, what is the frequency of a wave that takes 0.12 seconds for the whole wave to pass by? Well, gee, if 0.12 passes by, then the frequency is going to be 1 over the period, right? So 1 over 0.12 is approximately 6 million.
6 million?
I'm kidding. 1 divided by 0.12. 8.3333 hertz. Yeah, that's a pretty easy example. How about what is the wavelength? Hey, we already did that one. Look at this. The wavelength was this, and I used V as F lambda, right? So 343 is 440 times lambda. So it's going to be 343 meters that it goes in 1 second divided by the 440 cycles it's divided into. Yeah? I bet you guys want to try those, don't you? Whiteboards. Yeah, you got to take a planner though. There's one up here. You want to take one of these? Just tuck it into your arm. Try that one. That's a good one. Yeah. Yes, you can. Make sure they work. Should we make sure they work? Do you think we should? Be bad to sell. I think that's good. I'll guarantee that marker. If it quits on you. There you go. Yep. Whiteboard, whiteboard, whiteboard. Whiteboard, whiteboard. Whiteboard, whiteboard.